Good day. Our group was assigned on discussing the lime and silicate industry. Let's proceed. In this part, I will discuss about the background and history of lime and silicate industry. Let's talk about lime background first. Lime was being used for over 2,000 years now. Some of its uses and application are for construction, agriculture, chemical manufacturing, pollution control, water treatment, and others. Lime became a vital ingredient for our society that it is ranked for in terms of annual production in tons. Moving on, we have two types of lime, the quick lime and hydrated lime. A lot of people are confused or confusing lime with limestone, thinking that they are the same thing. Note that lime is just a substance derived from limestone. Let's move on to lime history. Even before the rapid growth of the chemical industry in the 20th century, lime has been widely used for building and agricultural material. Now the timeline of the lime history. In 1500 BC, lime plaster was used to build the Crete, which we can find in Greece. In 221 BC, the first completed Great Wall of China was built with lime mortar. In 27 BC to 1480, Vitruvius, who is a Roman engineer and architect, observed that limestone was lighter after it was removed from a kiln. He reported that about one-third of its weight was removed after burning. However, he was not able to determine the cause of the phenomenon. Not until later than 1756, Joseph Black discussed in his work that the source of the weight loss during burning in a kiln was the loss of carbon dioxide. Let's proceed now to silicate background. Silicate minerals make up most of the minerals found in rocks on the Earth's surface. Examples are quartz, feldspar, mica, amphibole, pyroxene, olivine, and others. Moreover, silicate is a compound of silica in the form SiO4. This compound is a major constituent of granite, slate, concrete, brick, and ceramic wares. Other uses or application of silicate are it is used for adhesive purposes due to its adhesive properties, used to form cement, and thermal insulation and sound absorption by intumescence. Lastly, the silicate history. In 1880, Johann Nepomuk described the basic technology and process for the production of silicate and its possible uses in his study. In 1830, Dr. Louis Feuchtwanger and Professor Dobereiner were the pioneers of the rise of sodium silicate in America. In 1832, Feuchtwanger carried and ran some tests on the cannons that are being used by the Brooklyn Navy. What he did, he coated the cannons with sodium silicate and asphaltum, which prevents the cannons from rusting for several years. Lastly, Gossage produced soap using soluble silicate for his company called Crossfields. At that time, Crossfields became the leading soap and detergent provider. After a few years, the company became a part of the Unilever Group.
Lime market is fragmented, which makes the vendors deploy different growth strategies to compete in the market. It is governed by the sales of two kinds of lime products, including hydrated lime and quick lime. This industry is also being driven by the growing construction industry globally. Asia Pacific is the leading region in terms of production, and it is also expected to continue having a healthy growth rate in the coming years as well. The growth of the construction industry is one of the major factors on the demand growth rate of the hydrated lime. Hydrated lime has its application in providing the steel products in protection from corrosion as well as in impurities. It is like a coating on the products, which helps to neutralize the acid of the slag. There were key players in the global market, and those were the Lois Group, Carmeus Group, Greymount Limited, Mississippi Lime Company, Norkdar Corporation, Ognayovo KJSC, and the Sigma Minerals Ltd. The Lois Group holds over 10% share in the lime production globally, which makes it the leading company in the lime production as well as in the mineral production. In addition, the Lois Group has an excellent quality of its product, which is liked by the consumers worldwide. It serves industries like steel, environmental, building and civil engineering, pulp and paper, and agriculture industries, and it was distributed across various regions. In the Philippines, HT Mining Products Resources Corporation is one of the largest and the leading lime product suppliers in the Philippines. The company produces high-quality products such as limestone, calcium carbonate, agricultural lime, quick lime, hydrated lime, and calcium hydroxide, which all carry the brand name Limpong. Whereas for silica market, silica gel is greatly produced because it is one of the cheapest and the easily available moisture absorbents worldwide. It is highly consumed in pharmaceutical packaging to protect medicines from moisture and other impurities. There were key players of the global silica market, and those were BASF, Clariant, Evonik, Solvay, and W.R. Grace. Clariant, which was mentioned, produces silica gel desiccant bags under the brand name Sorbit. It is used in different industries. In the Philippines, OCS Silica Island Mining is a company with a major play of role in selling and marketing the silica materials, like silica quartz and silica sand. It is also the first company to conceive as an option to mitigate the threat of mining squabbles among concerned parties over business and environmental issues.
In the lime industry, lime has a wide variety of applications since it is a natural raw material that has high versatility. For diving into the common related products in the lime industry, one should first know the difference between the two common kinds of lime used in this industry. The first one, calcium oxide, also known as quicklime, is produced when crushed limes are heated into about 1100 degrees Celsius, wherein the carbon dioxide is released and therefore leaving only the calcium oxide. After heated, the produced lime is then crushed and milled into the needed or specified fraction. Calcium hydroxide, also known as hydrated lime, is produced when quicklime is treated with water during the process called slaking. Hydrated lime is also used in building constructions because a concrete mix added with hydrated lime would produce a denser and more water resistant concrete product. This would result to reduced losses due to breakage and would create more precise edges and corners. Refined sugar is one of the most common products related in the lime industry. Hydrated lime is added to the harvested extract or juice from sugar canes and sugar beets to increase the pH level. It is also used to react to the impurities to aid in the formation of the insoluble organic calcium compounds, which could then easily be removed during the process. During the production of butter, lime water is commonly added to the cream to decrease its acidity prior to pasteurization. Casein, a major protein found in milk, is also added with lime and sodium fluoride to form calcium caseinate. In the silica industry, silica is one of the basic raw materials needed in the development of other industries such as the glass and ceramic industry. It exists in different crystalline structures and shapes. Quartz, on the other hand, is a kind of silica crystal that is considered to be the second most abundant mineral. Industrial silica sand is often the term used in describing high purity silica sand products. It is used in a lot of things that we use in our daily lives, such as abrasives, ceramics, electronics, and absorbents. Glass production, silica sand is one of the key ingredients because, as mentioned before, it can resist high temperatures and has consistency in terms of its appearance, especially as a finished product. Silica is also an essential product when it comes to making ceramic products. Silica helps in the regulation of the shrinkage and drying, modifications in the thermal expansion when the ceramics undergo furnaces, and the improvement of the appearance and the ceramics structural integrity.
So let us now discuss the statistics involved in the lime and silicates production industries in the past years. So let us begin with the lime production by country in 2019. So the three leading lime producing countries in the world as of 2019 were China, the United States, and India, with production volumes of 300 million metric tons, 16 million metric tons, and 16 million metric tons, respectively. In this year, the total combined production of lime from the whole world is 432 million metric tons. Let us now go to the lime production worldwide from 2010 to 2020. So from this graph, it is visible that the lime production has had an increasing trend throughout the 21st century. From 2010 to 2014, there has been an increasing trend in production, although this trend slightly declined in 2015 and 2016. But as the year 2017 approached, lime production has reached its all-time high, steadily increasing until last year, where it slightly declined, probably because of the pandemic. So let us now go to the world silicates production in 2019. So as with lime production, China has also dominated silicates production throughout the 21st century. They, together with Russia, Norway, and the United States, has produced a large majority of the world's silicates. So if we look in this graph, we can also see that even though China, Russia, Norway, and the US are all in the top, China is far more superior when it comes to the silicates production, as with the lime production, of course. So let us now analyze the geographic structure of the production capacities of sodium silicates. So we all know that silicates are one of the most useful minerals that are utilized in our modern society. With this, there are a lot of forms of silicate products, but the most prominent and widely used are the sodium silicates because of its utilization in multiple industries such as soap, paper, and food industries. From this graph, we can see the main regional producers of sodium silicate products in the 21st century. China accounted for the majority of the production with 42%, followed by Europe and North America with 19 and 13% respectively. So if we analyze this graph, we can also see that China has dominated the sodium silicates production. Let us now go to the China sodium silicate market price, or size rather. So knowing that China produced most of the silicates throughout the 21st century, and that most of the silicates are in the form of sodium silicates, it would make sense that we analyze how they plan to allocate these sodium silicates in the future, and also see how they've done it in the past. You can see in each succeeding year that has passed until 2020 and now 2021, and in the 4 years that will come, China's allocation of each or of the sodium silicates will almost stay the same, although these columns rise because it is projected also that their sodium silicates production will also increase. So with China being the main producer of sodium silicates, they're also the main consumers. So this makes sense with the last graph that we have shown, where China allocated all of their sodium silicate productions. So as we can see, they utilize sodium silicate in their vast manufacturing industries, including detergents, catalysts, paper, and many others. So let us now go to the world consumption of other silicates in 2017. So although sodium silicate is the most prominent, it is undeniable that there are also many types of silicates that exist. This graph, this graph above shows the world's consumption of other existing silicates and their respective fraction. So if we look into this pie chart, we will note that zirconium silicate seconds sodium silicate in terms of consumption throughout the world. Zirconium silicate is followed by potassium silicate, calcium silicates, magnesium silicates, and lastly and leastly, the ethyl silicates.
And here, we are going further into the lime industry. We will be discussing the lime production. The production of lime begins with the quarrying and crushing of limestone. After extraction, the limestone must be crushed in order to obtain smaller pieces of it. It is then fed into a kiln where calcination occurs. In here, limestone will undergo thermal decomposition, which results in the formation of calcium oxide, or quicklime, and the emission of the carbon dioxide. In order to achieve a complete decomposition, the temperature must be kept constant and the dissociation temperature of the carbonates. So this means that it varies depending on the type of limestones that were burned. In addition, the chemical reaction is reversible, and this is why carbon dioxide must be removed to prevent recarbonation, because it might be reabsorbed by the lime that can diminish the quality of the product. The product of calcination can produce another type of lime, and this is through the process of hydration, or also known as slaking. And here, the quicklime reacts with water. This can be done with the use of hydrator, where a precise or sufficient amount of water is added to the quicklime, and the mixture is stirred and agitated. The product is called calcium hydroxide, or hydrated lime. The third product is made through calcination and sintering of dolomitic limestone at a very high temperature for about 1400 to 1800 degrees Celsius. And this is why it is called dead burned dolomite. In here, it no longer reacts with water. So this is the summary of the inputs, emissions, and byproducts from the lime production. starting with the inputs or the raw materials needed for the lime production. First one, of course, is the limestone. As mentioned earlier, it is a type of sedimentary rock which is a source of calcium carbonate. It might be a high calcium or dolomitic, depending on the content of the magnesium. Next is fuel. So this is the material that is burned in order to produce heat and is required for the thermal decomposition or calcination. Lastly, water, which is used for the hydration of the calcium oxide. Next are the emissions. So these are the gases produced or released in the lime production. These are the carbon monoxide, carbon dioxide, sulfur dioxide, and nitrogen oxide. So these are the emissions from the kiln after the calcination process. So these are dependent on the fuel that is used to burn the limestone. Next are the byproducts. So the first one is the stone spalts. So these are the limestone that did not meet the size requirements of the kiln feed. So what we can do here is it can be further processed to produce limestone pebbles and granules. Next is kiln dust. So this is released from the kiln after the calcination process, which can be used for industrial and stabilization remediation.
Lastly, this is the flow diagram for the three major products of silicate industry. The production of quartz begins as silicon reacts with oxygen forming silicon dioxide. This process is known as oxidation. In igneous rocks, quartz forms as magma cools. Like water turning into ice, silicon dioxide will undergo crystallization as it cools. Crystallization is a process wherein, as a solid form, its molecules will be highly organized into a crystal structure. Slow cooling generally allows the crystals to grow larger. Quartz is the second most abundant mineral in the Earth's crust. Quartz can be manufactured into quartz glass, which is valued for its exceptional purity and serves a wide range of application. Quartz glass does not contain additives. It is valued due to its distinct and high value characteristics. Among these are because of its low coefficient of thermal expansion, high gas permeability, and extensive optical transmission. Quartz undergo washing and drying process. Dirt, moisture, and contaminants present in the natural quartz are removed in the early stages of processing, which may affect the quality and performance of quartz glass to be produced. Next is comminution. The objective of this step is to reduce the raw quartz into a size suitable for the fusion method. Natural quartz undergoes a series of size reduction steps, such as crushing and milling. Afterwards, the particle size is analyzed and larger grains are separated. For flame fusion, thermal energy is used to break the strong silicon-oxygen bond. With increasing temperature, more bonds are broken and result in the less viscous flow of quartz. Natural quartz passes through a chamber with a high temperature hydrogen-oxygen flame until the starting material is fused. The quartz glass is quite complex to thermoform due to its high melting point and stiff viscosity, allowing it to be formed on a very narrow temperature range. If the temperature is too low, the glass is solid. If the temperature is too high, the glass is less viscous and volatile, resulting in evaporation of the parts. In addition to this, single or multiple annealing steps are required to relieve the thermal stress and prevent fracture induced by hot forming. Welding, collapsing, elongation and compression, and glass blowing are examples of hot forming methods which a manufacturer can use in order to enhance the glass product. Silica gel appears a slightly transparent white solid substance. Silica is a high active, porous material with the internal surface area being large. Therefore, it has strong absorption capability on the liquid or gas. The silica gel can be manufactured through a reaction between water glass and sulfuric acid, and further gelling, washing, desalting, amidation, and drying. General industrial silica gel has a mechanical strength of 85 to 95%, water content being low 2%, and moisture absorption rate of 25 to 30%. These are the summary of the inputs, emissions, and byproducts in the three products. For the inputs, we have quartz, which is a crystalline mineral made of silicon dioxide. Next is the hydrogen-oxygen flame, which is a mixture of hydrogen and oxygen that is burned used for making glasses. Lastly, the water, which is used for washing a product. The emissions are the gaseous pollutants such as carbon monoxide, carbon dioxide, sulfur dioxide, and nitrogen oxide. And for the byproducts, we have the carbon dioxide.